Okay, so moving on to section 1.4, let's talk about division of whole numbers. So division of whole numbers, that's another one where the order matters. If we say 40 divided by 5, that would be different than saying 5 divided by 40. This, as it's written right here, 40 over 5, this is just another way of writing 40 divided by 5. It doesn't matter if we use this symbol or if we use the division, but we do have to make sure we have the right order there. If it's written as a fraction like this, it's always the top number divided by the bottom. You know, when you're reading, you go top to bottom. Same thing goes here. If you're reading this, you go left to right. It's 40 divided by 5. The only weird exception to this is if you're doing it if you're doing long division. You would actually write this 40 divided by 5 if you're doing it as long division. I don't generally recommend long division because you guys are allowed to use calculators, but you would write it like this if you're doing it as long division, 40 divided by 5. You read that right to left. So in any case, if we're typing this into the calculator, we'll actually end up using 40 divided by 5. I use the slash key, so I'm actually using my keypad. Let's see, where is it on this keyboard? I guess it's divided by right there. But it's the slash key. On your keyboard, it's probably to the right of your period key, your decimal point, if you want to call it that. It's that normal slash. I guess you can't see what I'm typing. All right, so 40 divided by 5 looks like that. And this would not work with a backslash like that. This is this is the other slash that's on your keyboard, the one that's above your enter key. That one means something else, and it actually doesn't mean anything really there. All right, so how division works is it's kind of working the other direction from multiplication. Let's talk about what it would mean. Why this equals 8? Why does 40 divided by 5 equal 8? Well, if I had, let's do 5 groups of 8. So I'd have 1, 2, 3, 4, 5, 6, 7, 8. That was 9. I can count. 8. And I had 5 of these groups. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5. I have 5 groups of 8. In total, if I was to count these up, if I actually gave, I think I gave 8 dots for each of these, there would be a total of 40 here. And so we would say 5 times 8 is 40. This is looking at it from the multiplication perspective. But if I was to look at this the other way, if I said, okay, I have 40 things and I want to divide them into groups of 5, well, how many groups do I get? I get 8. Or if I wanted to say 40 divided into 5 groups, again, this would be 8 of them. This can be thought of simultaneously as dividing into groups of 5 or dividing into 5 groups. Let's think of this as, let me try to, which way is going to work better? Let's think of it as dividing it into groups of 5. Yeah, I think groups of 5 is the easier way to think of this for the stuff that's coming up. All right, so if we wanted to try to do something like 20 divided by 0. So I have 20 dots, 1, 2, 3, 4, 5, 6, 7, 8, whatever. I have 20 dots. Let's pretend there's 20 of them there. And I want to divide them into groups of 0. Well, how many groups of 0 does it take to get 20 dots? Well, let's see. I'm still going. All these groups have zeros in them. I can keep going for a while, and I'm not going to get up to 20 dots ever because there's no dots in any of these. I still have 0 dots accounted for. So if I'm trying to divide this into groups of size 0, it's not going to work. This doesn't work. It's actually what we say is undefined. So if I'm trying to take 20 and divide it by 0, this doesn't work. Now, let's think about the other way. What if I wanted to do 0 divided by 20? Let's think, does that work? Well, I want how many groups of, well, each of these groups should have 20 in them. So let's say, a group has 20 dots in it. How many of those groups should I have to account for 0 dots? Well, I need to have 0 groups. And, well, if I have 0 groups, then I actually have 0 dots accounted for, so it looks like it actually works. So 0 divided by 20 is 0. I can take 0 dots and divide them into groups of size 20. I just get 0 groups there. Let's compare this to 20 dots and dividing them into groups of size 0. No matter how many groups I have, I still have 0 dots. I'm never able to get up to those 20 dots. It's a little bit weird. You know, you can take and divide 0 by any number and you end up getting 0 there. So 0 divided by 20, 0 divided by 3, 0 divided by 4, those are all equal to 0. But if you try to flip it around and you say something divided by 0, this is now undefined. And it's worth noting, whenever something happens in math and we say it's undefined, mathematicians have a tendency to want to define everything. And so when we go out of our way to say something is undefined, it's worth noting. All right, let's talk about 62 divided by 6. Let's first do this one kind of by hand to see what would work. I'm going to treat this the same way as what I was doing the other ones. I'm going to talk about individual groups with 6 dots in each of them. I want to figure out how to get 62 of those dots. Well, let's see. If I have one of the groups, 1, 2, 3, 4, 5, 6, I would get 6 dots. If I have two of the groups, I would have 12 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have 10 groups of these dots with 6 each, this accounts for 60 dots. And then there's 2 left over. So what we would do is we would say that, well, 62 divided by 6, this is equal to the quotient here. Sometimes this is called the quotient. Is 10, because there's 10 groups, and we have a remainder of 2. There's 2 that are left over. Now, doing this by hand is not a good way of going about it in general. This was easy enough numbers. We can count up in multiples of 6. I was actually seeing that 60 is a multiple of 6, so I can get up to 60 dots here fairly quickly. And then there's going to be 2 left over because there's not enough for another full group. Let's see what happens when we type this into the calculator, though, because that's most likely what we're going to do. If we want to do 62 divided by 6, we end up getting something that looks like this. 10.333333. Those 3's actually go on repeating forever. So, how in the world does this number relate to that one? Well, you can see first off there is a 10. And this is saying that there are 10 full groups. This is the same 10 as what you saw right here. So 60 divided by, not 60, 62 divided by 6 gave us 10.3 repeating. We do this line over the top of a number to say that it repeats forever. All right, so the 10, these are the whole groups. And this 0.3 repeating, this is the part that this is somehow talking about that remainder. It's describing that remainder. It's saying, well, if you know your fractions, you might recognize 0.3 repeating as a third. And let's see, 1, 2, 3, 4, 5, 6. If I have a third of a group here, let me cut off that third. You can see I actually have 2 of those dots. So that 0.3 repeating is actually kind of encoding this remainder. It's saying we have a third of a group. But in order to figure out how many dots is in a third of a group, well, this is a little bit tricky. Let me take that 0.3 repeating and multiply it by the 6. The actual explanation for why I would do that multiplication is kind of the same reason I would do the multiplication here. If I have 10 groups with 6 dots in each of them, that gives me 60 dots. It's 6 times 10. If I have a third of a group that has of 6 dots, well, a third times 0.3 repeating times 6, I could actually just ask my calculator this and verify. So let's type that in. 0.3. Just do a bunch of 3's on there and just hold down 3 for a little while, times 6. And you can see I get 2. This actually did round a little bit. These 3's, obviously I didn't go forever with these 3's. This is not exactly equal to 2. This would actually be equal to 1.99999999999, and so on. And then 8 at the very end, I believe. So it wouldn't be exactly equal to 2 if you were to do this out by hand. You could kind of see that, but it's close enough. And the reason for that, the reason it's not exactly 2, is because I didn't go forever with the 3's here. So in any case, let me reiterate what how we do that process. Let's do it with this next one. 133 divided into groups of size 4. Okay, so 133, start out with that, 133 divided by 4. And this is going to be 33 full groups and 1/4 of a group. 33.25. This is 33 as the quotient, and 0.25 times 4. I'm multiplying by 4 because it's groups of size 4, so I'm multiplying by 4. This gives me 1. 0.25 times 4. You know, again, if you recognize your fractions, you see 0.25, you see that as a quarter. That's one of the 4 parts of the group. So in any case, this is the remainder. So again, what I did is I did my division. I got 33.25. The 33, the whole number part of this, I just write down. That's my quotient. That's how many full groups I get. Then I'm going to take whatever that part is that follows the decimal point and multiply that back by this divisor, by the thing I divided by, to figure out how many are left over. Alright, let's say a pump can deliver water at 200 gallons per minute. How long in minutes will it take the pump to fill up a 50,000 gallon tank? So one of the things you're going to need to be able to do is to figure out which operation, you know, how are we going to write this? How are we going to use math to solve something like this? Well, this pump is delivering 200 gallons per minute. So if it was to pump for, I don't know, 3 minutes, how many gallons would that be? Well, 3 times 200. This would be 600 gallons. If I wanted to go all the way up to 50,000, then I'm saying, okay, what number, something times 200 equals 50,000. You know, 3, here I had 3 times 200 equals 600. If I'm saying, okay, well, some number of minutes for pumping times 200 gallons per minute will give me 50,000 gallons. If you ever find yourself asking the question of what number times this equals this other number, you're really asking a division question. What number times 200 is equal to 50,000? Well, I'll solve this by saying that blank is 50,000 divided by 200. The nice thing about that is I can plug it into my calculator. 50,000 divided by 200, which gives me 250. So it would take 250 minutes to fill up this tank. Let's make sure, this would be, what, a little over 4 hours? That would be 240 minutes. Let's see, how long in minutes will the tank pump to finish? Okay, so it's not asking me the number of hours or anything like that. I'm just going to go ahead and say this is 250 minutes. Whenever you're going to give a final answer for a question, you always want to make sure you read back through what was actually being asked for to make sure you're answering the question.